Hi everyone, welcome to a Wolfram Language Design Review. Today about LLMGraph. So let's start off with the basic concept here. I'm just getting over being sick here, so I might sound a little bit croaky. Okay, go ahead.
So the idea, as I put in the image at the top, the basic idea is that this is a scheduler. Yeah, you have several LLM interactions that you want being handled, and there's no reason to put them in a line and waste time waiting for one to complete, where you could send multiple of them to happen at the same time. So even more than in things like net graph or other graph evaluation framework that we have in the language, everything is asynchronous here, and you can really save time by managing your dependencies well. So this is automatically taking care of that, basically. So that's the core issue, and allows you also to at the same time represent like a richer interaction scheme where like one LLM is fed with outputs from other LLM calls. So this addresses both issues, basically.
Okay, but so what happens if I want to okay, so is this a graph or what? I don't understand how do I represent, what does this mean?
You can represent it with the graph. So here, okay, we have a design limitation here that we are addressing with a simple syntax. And the design limitation is we don't have a generic port language in port syntax in the language. We are working on that, but it's not there yet. So right now, the way this works is that you can automatically basically figure out connections by mentioning one node in the other nodes. So in this case, like node 1 is a prompt that will get evaluated. Node 2 is another prompt. And node 3 takes the first two prompts and decides something like that. This is a very simplified version.
Because you're programming, it's kind of silly.
I mean, well, you can imagine that node 1 is doing, for example, like is calling a Wolfram Alpha API to try to get the answer to a question.
Okay, I don't understand this. I don't understand. I mean, node 1, what's the payload of node 1? I mean, this graph, like in NetGraph, let's remind ourselves how NetGraph works. Okay, NetGraph has a bunch of layers, and it then has a definition. It has a bunch of layers as its first argument, and then its second argument is the connectivity of those layers.
Exactly.
Right, as a graph. Now, here, I'm not seeing that. I don't understand that. Why am I not seeing the actual active nodes specified? And then just
so you're asking why you don't see the connectivity. You don't see the connectivity because, I mean, that would be the second argument. And in the tentative page in CDS, we do have that. The only problem we have with that is that, okay, look at the first example in NetGraph, for example, that you have a net port input and 2 are going to 3. So we don't have a generic language construct for net port. And we decided that we shouldn't invent a new one specifically for LLMGraph. It should be a bit more general port. So we are also discussing that with Charles. But I mean, the general syntax will have a second argument where you can force the connectivity. But this doesn't.
I'm totally confused. I'm sorry. I'm totally confused. The main thing is the nodes here are LLMs. An LLM takes a certain input, it cogitates on that input, and it produces a certain output. That LLM might use a tool, it might do other things. Exactly. Conceivably, it doesn't need to be an LLM. It could just be an API or a function that takes, an output from one place. And I mean, just to understand, in order to go, an LLM has to reach a stop token before it basically feeds itself onto the next stage. Is that true?
Yes, with an API, you typically don't control that. But yeah, I mean, if you want, you can, but you can also let it finish.
No, I understand, but fundamentally, what's happening is the connectivity is the streaming, for example, is happening one could imagine the whole system streaming itself, goes from one thing, and even when it's not finished, it's streaming it into another node, which is then streaming it onto another node, and so on. See what I'm saying? There's no reason that it has to be synchronized.
Well, you need, like, for example, in this case, the node 3 has a template input where you get the output of node 1 and node 2.
I understand.
So if you don't have that output,
I
the point is you can get a partial answer from an LLM, but you cannot do a partial request. The request is always the full payload.
That's true.
So I understand what you mean about that. There's no way to send a partial node 1 result out. But I understand what you mean. Like,
but let's be clear why this is. It's because an LLM, by its kind of transformer nature, expects the full prompt to be there before it starts making up the new pieces.
Exactly. The past has to be all there.
But that wouldn't necessarily be true for all APIs, for example.
No, in general, you might have something
fine.
that
but for now,
sooner.
We're going to assume that after there's an input to a node, and that we wait until the output is generated, the full output is generated from that node.
Mm-hmm.
So I don't really understand why. I mean, the nodes here are generally LLM synthesizers. Is that correct?
Or LLM function. I mean, in this case, the first two, this is a very, very simplified syntax where you don't use, I mean, you could put the LLM function or a string template. This is just a string template, like a naked string template. So the first two nodes are like LLM synthesized, and the last one is an LLM function that takes the output of the first two. So this one has this is like a net graph with no input. Is a very simplified thing to illustrate the concept.
All right, so fine, but I mean, but what we're really doing
we have a richer example. We have a richer example below if you want to see the network with also input. Like if you scroll like below all the syntax and stuff. Yeah, this example here. So now you have like three nodes. Two of them take an input, which is topic. The last one, stupid jokes, is like a random joke that doesn't take any topic. And then you have a decider that takes the output for all three and decides which one is the best. So this is like a bit more like, is a stupid example, but it like simulates something like more real happening where you get an input.
Okay, but I don't understand the point of this to begin with. Okay, so there is an implicit LLM synthesize at every node here as the first argument of LLMGraph. Is that true or not?
Yeah, it will happen on the nodes when the nodes gets evaluated.
No, but look at what NetGraph does. Okay, NetGraph has a bunch of layers that do things. They're essentially functions. Okay,
exactly.
The second argument is the connectivity information.
Exactly.
Okay, that's the pattern that we should be following here. So I don't understand that. It's very obscure what's going on here.
Okay, this is. Can you open the CVS page for LLMGraph?
Yeah.
So you see that we have like the first syntax is what you see here. Then we have the futurized syntaxes with what you specify the connectivity. That is the full syntax. So the point is you can easily auto-discover the connectivity by looking at the input name, the string slot, the string template slot in the nodes. If you want to manually connect them, you can. And my only problem with that is that we, as I was saying before now, we cannot fully specify that in the language right now without a new symbol. Because you would specify that, like the decider node has like 3 inputs. And that would be, in the neural network framework, that would be net port decider 1, 2, and 3, or like normal joke, funny joke, stupid joke. And but we don't have an equivalent of net port.
No, but we don't even care because we're trying to make a prompt. In these cases, what we're trying to do is assemble a prompt. So it's nothing to do with ports. It's more just like string templates, right?
Exactly, and this is what is happening. So like if you look at the agenda notebook, that decider node, it has a string template where if you look at the formatted one, you can look in the agenda notebook is better. Like this is more like design. Yeah, in that one, exactly.
Let's go back to the beginning here, okay? Well, we can look at this example.
Mm-hmm.
So let me just slowly look at this example.
Mm-hmm.
Okay. Okay. Where do we start? So in other words, what we're doing here is somehow, and presumably, is this a function? Is LLMGraph a function that applies to things or what?
It's like NetGraph. It takes a spec and generates a symbolic LLM graph that you can then evaluate.
But okay,
it's like imagining that as a richer LLM function with more internal structure. LLM function stays as it is as long as you don't evaluate it, and then you can evaluate it on an input.
But this isn't. It doesn't by its name say that it's a function.
Even NetGraph doesn't say that by its name, or NetChain, but they are.
That's true. But okay, so how do I apply this thing?
Well, this is the auto-discovery method that we have here.
No, I'm asking, wait. How do I get the thing to run? Do I say LLMGraph of spec open close, or what do I do?
Yes, exactly. Yes. We have two proposals here, like direct evaluation, which is the easiest one if you want to just try it out, which is we can use the object directly.
Can I run LLMGraph or not?
Unfortunately, no, because it is in the proto, but the service framework is also there's a revamp there, so they are interacting badly. I can show you the thing in real time if you want, because I have loaded locally.
Okay, well, but let's not worry about it for a second. Okay, I'm still trying to understand. I think this is muddle. Okay, so let me just try and understand it. Right, so the goal is to take topic in. That's the input, right?
Exactly.
Then I'm just completely obscure to me how this is supposed to work.
This is looking at all the nodes, yeah, like and is analyzing them. The first node has an input which is topic, which is is not provided by any other node because there's no topic node, so you must provide it yourself.
What do you mean there's no topic node? There's no. You're not using the name topic.
I mean, these are template slots. Yes, this is doing auto matching of a name. That's the advantage of this. I mean, if you don't want this, you need explicit connectivity.
No. It matches a key and an association to that name.
Exactly.
So
yes.
Each node has a name. So normal joke, funny joke, no? And each value in this association is actually a shortcut for LLM function. So LLM function takes topic as input and will run LLM synthesize on the generated prompt. So the node normal jokes expects an input parameter which is named topic, and in the decider node, the input.
I see it. Is the normal joke and so on.
Yeah. So the output is taken to feed this decider node. And that's how the links are resolved.
Okay.
That's why we don't need the second argument, because we name the slots.
Okay, but so somewhat okay. I'm just trying to understand. Ethan on our live stream is asking, what about agents? How would agentic patterns fit in here? Do you want to address that now? I'm going to ask that in a bit, but do you want to address that now?
Well, I can answer. I mean, this is a step to that. We also had in the pipeline that, but we are doing one design review at a time. That is like a static graph. That is a dynamic graph generation. that will use the technology that we're building here to handle concurrent requests.
Well, are we sure that we don't want to? Because I mean, graph is not a dynamically built thing.
No,
we have new concepts of dynamically built graphs, but that's not what graph does. So it would be worthwhile to know what we imagine the dynamically built version of LLMGraph will look like before we make a mistake on the design of LLMGraph. So can you say something about what the dynamically built LLMGraph design should look like?
I don't even think it should look like a graph, because the graph is a byproduct of the graph is a trace on the evaluation of the agent.
Yeah.
I imagine the agent is basically an LLM configuration with a bunch of tools, a bunch of resources, a bunch of prompts that you have, and a way to, like, an initial prompt that is able to orchestrate, starting from the initial task, to call all the things and decide what to do here and there. So it's like a powered up LLM functions that does a lot more things inside.
Well, I don't know.
But we already have a.
Yeah, go ahead.
I mean, we already have a way to represent resources in an LLM interaction, which is the LLM configuration. So the way I imagine the agent to work is building upon that. The agent is a central prompt that can like, imagine like a meta tool caller, where you take your initial input, and then you say, oh, now I call this tool, and then we look at that, we call the tool for it, we feed it back, but then it can also do some other things, like now I want to know what's in the long-term memory, and that's like another tool. So I think we can feed that into the tool business by maybe is mostly packaging.
I think what we need there are various standardized tools, of which we already have some, but we need others. And I mean, I'm not sure you guys are going to be working on that, but I mean, there are various agent projects that we're supposed to be doing, yeah, perhaps not for this discussion. But I do think probably that the right way to think about that is using essentially standardized tools.
I think so. Yes, I think so. I mean, you have like normal API calls, and you have like more personalized tools, like short-term memory, long-term memory, or you might have like file interactions and other things. Or you have like a planner that does extra reasoning steps if you're stuck, or at the beginning to lay down the project that then the LLM will follow. And
what does LLMGraph have to do with any of that?
I mean, these things we can handle concurrent operations basically very efficiently, and then we have a way to represent what's going on. And because one thing you can do, which is part of the meta programming around the agent, is impose the structure on that. For example, you want to check that the agent is making a tool call and make sure that it's doing that at least once. So you want to track the interactions and see what's going on, and the LLM graph is a natural way to trace what's going on here, because you can instruct the LLM and say, you can ask me for multiple tools, and then we can have parallel tool calling. There's no reason to do tool calling one after the other. And it can do like it can ask several other like sub LLM interactions that can happen at the same time. So this goes naturally with the orchestrator
how does
business.
In the AI tutor, do you know how that has been built inside?
No, unfortunately. I can check. I can check with you.
Yeah, because I know that, for example, the QA system for that does many things there are doing parallel calls to LLMs. So it'd be good to know if this LLMGraph design is actually usable there or not.
Yeah, no, I mean, that could be a consumer. I mean, if you're using something custom that we can package here as part of the syntax, yeah, that's awesome.
let's see. I mean, is this in fact useful? Do you know of what are some real use cases of this LLM graph thing?
Well, right now is mainly used like if you have your if you already know what you want to do. You already know you want to check several sources and match them. This will allow you to do it efficiently.
So, for example, in the Notebook Assistant, is there a use for this?
Well, if you want to query, I don't know if there is like only one LLM called on the history to prepare the RAG, but if there's more than one, this could be used to handle that. But I think that the Notebook Assistant is working at the lower level of LLM services because of like I mean, I have to check, but there's some it's going to be lower level to manage some front end interaction and stuff. So I have to check with Rick. But we designed this together at the beginning.
All right, but I'm still trying to understand. So for the agent story, okay, the primary concept there is essentially a collection of standardized tools and or LLM functions.
Yeah.
That are potentially glued together. Well, what's complicated there is that the main kind of thing that causes it to keep going, I mean, the LLM will just keep rolling on until it gets to a stop token. A tool call could then, I'm just not completely clear how, in the case of a, you give the agent an initial task. It has something that keeps the agent going until it thinks it's finished that task. Is that thing that keeps it going an LLM graph or something different?
I have a good example for this that might clarify. How we have two methods of doing tool calling. One is directly using the API, and one is the custom one where you can instruct in the prompt the LLM to use tools. So the second one is the one we have been using since the beginning, even before there was official tool support in APIs, because it works for all LLMs, even the ones that don't have this support. How does it work? You basically say something like, I have this question, give me an answer. If you don't know, you can call a tool using this syntax. So if the LLM decides, in its like generation process that it wants to call the tool, it will answer you with that syntax. You check for that in the stream, and if you see that, you stop the generation if it didn't stop automatically, and you perform the computation. And then you prompt the LLM again, saying, this was my original question, and this is the result of the tool call. So this is how the agent works, basically. Yeah, like the agent says, like instead of just a tool, says like it's basically a richer tool ecosystem. Like you can ask the planner to give you a plan if you think you need one, or maybe you have to at the beginning if you don't have one.
Let's walk through what it actually looks like. Okay. All right. So what does, if we have a thing called LLM agent, what does it look like?
I mean, to me, is like a richer LLM function.
Okay.
That takes an input and has a bunch of tools, which could be just packaging the LLM evaluator, or
so let's say it's it's got a list of tools that has available, and those tools include things like things like the memory tool and the web search tool and the computation tool, et cetera, et cetera, et cetera, et cetera, et cetera, right? Including a zillion specific. I mean, we don't need to produce specific tools for a lot of these things because they're just functions in the language. So these just become just pieces of Wolfram language code. They don't need to be specific, right? There may be conventions for things like the memory tool and so on, but they don't really need to be custom written because they're just,
No. You can directly use a system function. It may be useful to split them just for the LLM sake in order to basically qualify different actions that you can take.
Yeah, okay.
In order to just
fine.
prime it.
So all right. So then what happens here? So you start, you feed this. Let's say you feed an input,
Mm-hmm.
or maybe you don't. Maybe it's just this, like LLM synthesize, for example.
Yeah, without an input, like what's the goal? Typically, this stuff has a goal.
No, but I mean, the goal is, it's like, write me a poem.
Yeah, okay, yeah, exactly. But I mean, but in the end, if you think about it, LLM function is like a resolved prompt, like it's an unresolved prompt for LLM synthesize. Just running the function is completing the prompt, and then the path is the same as LLM synthesize. You want to take a moment, pause, and see?
What?
This is this last verse. It says, take a moment, pause, and see.
Yeah. Okay.
So I mean, I think that the extra value in the agent business is the easiness of defining those things, like attaching or detaching them, and some work which is not LLM work, but is like normal code work, which is to police what's going on, and make sure that the requirements that you impose are satisfied or stuff like that. Which might be to do like
Ethan sent a page from the Llama documentation, which is yeah. I mean, there's a different group of people here who are supposed to be looking at this, so we don't really quite have the right. This is not the right meeting to go through this. But this is indeed something appropriate for us to look at. This meeting was supposed to be narrowly focused on LLMGraph.
Okay, but let me piggyback on what happened. Do you want to? I mean, LLMGraph is quite clear. Is like NetGraph and is handling concurrent computations and dependency, from one node to the other. If you want, we can hold this and do a joint design with LLM agent. If you think it's more useful to see them. I mean, the work on this is done and the function is basically ready. If we need to adjust the syntax to accommodate some other things, we can do it easily. But Timothée has done a nice job to like for example, if you scroll down to the bottom, you have all the timings that show. If you open the timing debug, there's a nice plot that is showing what's happening. Yeah, like we have implemented all the scheduler. You can as long as a node is it starts, it advertises to the orchestrator that it has started, and then it when it is over, you make sure that you check the dependencies and see if you can move on. So all this job is done. We can efficiently handle multiple concurrent calls.
That's nice.
Okay, this is one like a bit more realistic. You see, like this is like it's taking input as an input, which is like maybe imagine like something like a chat input, and the WS specialist says use a Wolfram language tool to answer the following question, and then you have the Burl LLM, and then you have some evaluator, and then at the end you have something that is merging things and making sure that everything has been done correctly.
What the hell is this?
This is like the internal structure. It's
what
like
is graph versus plot?
We are still working on those. Like one is just a naked graph and one is a graphics. But it's like
that's silly. Nobody cares. I mean, this one is presumably the more relevant case.
Yeah. Like we are adding like kind of the, how do you say, goodies like and things that allow you to get information as we go. So we're gonna clean them up before it's final, of course.
Okay, so what's a little weird here? So LLM graph, if I specify an LLM graph with no inputs, and I just say LLM graph, open bracket, blah, 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 close bracket, will it start evaluating or not?
No. We are, the proposal for evaluation is basically this one. So synchronous evaluation G is a fully formed LLM graph. So is LLM graph open close and is inert, as it is, like net graph. Net graph doesn't evaluate anything. It just does some internal validation.
Yes, I know. Yeah.
So this could inform you if you have like loops or stuff like that, something that is not allowed.
Right.
Then,
so LLM graph as such will just go, and I mean, I think we could do a little better for this icon, but it will just basically produce something like this. To actually activate it, you say LLM graph, open bracket, close bracket, if it has no inputs.
exactly. I mean, by the way, that icon is because the graph is the actual graph, and that graph is very simple. We can have like a default icon if you want one better. Yes.
Okay. So the concept here is, I mean, maybe this is a reasonable idea. I mean, is that these are string templates, and they could presumably be fully decorated string templates.
Yeah. You can use a template object or string template. Of course, this is just the simplest possible syntax if you want to type quickly. But you can use a string template with insertion functions, and also you can put an LLM function there to have maybe you want to use two different LLMs in two nodes. There's no reason to limit.
Right. So this is simply the name of the node. And that name of the node is effectively being used to represent the output from that node when fed to another node.
Exactly.
Correct.
Well, okay. Let me just think for a second. So fundamentally, I mean, there is some function that's applied to all of this. There's a default evaluator. So there's presumably an LLM evaluator here.
Yeah.
Which is, okay, so if I were to fully represent what's going on here, it would be LLM synthesize of, actually it would be LLM function of
prompt one.
This prompt here.
Yes.
Of N1 goes to LLM function of prompt 1.
Exactly. In that case, applied on nothing because you don't have any specific input. And same thing with N2.
Okay, but this in fact would be the actual LLM graph. Oh gosh, I don't even know how to represent that. Would be this without having been applied yet.
I mean, you can do open hash close and then make this into a function.
Fair enough.
If you, yeah.
All right, so that's what this
Exactly.
is.
Exactly.
Okay. There's something a bit weirdly backwards about this. But maybe it's the way that you've, let me think for a second. I guess it's one, I mean, you do this first with that prompt. No, I'm warming to this syntax, okay? I think naked strings should be assumed to be string templates, I think. I understand that there's the markdown issue.
So maybe we just need a nice way to escape it.
Yeah.
I mean, if it's really becomes a huge issue, we might, we could have a wrapper that says markdown, and we just put a string in that wrapper.
I mean, I think it's more cumbersome that the fact that we don't have a proper escape syntax for backticks in string templates,
okay, well,
which could be used to fix this. Yeah.
So how do we solve that problem? What is what?
You can have an option to say the separator in string template to decide it's not backtick, but
that seems troubling. I mean, how do we do that? How do you escape a backtick? Is the idea that you just use the full form of a string template? You don't like the backtick?
Well, in string form, our older function, it's a cumbersome. You have to do backtick period backtick, I think, something like that, to represent the backtick.
That's crazy, but that's probably
exactly. That's like super old syntax. Here, I don't think it's possible to escape it. So we have an undocumented template verbatim to do it, but it's not really possible to do it.
But that's because we imagine that these things are wrapped in a string template wrapper, so that one would never go inside. Right. I mean, I understand. So we need a way to escape it. Is there a good reason why /backtick wouldn't be the way to escape it? I mean,
well, I assume that if you do this and if you want to represent, backslash and then a slot, you can do // slot, and that's
sure you can escape the
a literal backslash.
Well.
Exactly. So, I mean, I don't see one, but I'm not the developer here, so I don't want to,
maybe
just
somebody
say
should
that there's
ask
no
Ricardo.
issue.
I think Ricardo would be the expert.
Okay, we will fold him in.
That seems like the right thing, and then at least we should provide WFRs to do various kinds of escaping and markdown, escaping markdown, all those kinds of things.
Okay, yeah, I understand.
But I think this is a decent idea so far as I know. I mean, send it out on LCC, see whether anybody has thoughts about it.
Okay, we will poke at it.
What is partial input? What does that mean?
So let's say that you want to do, like, it's like a marginal probability. You will integrate on a variable. Let's say, like, if I have, if I have that the input depends on A and B, if I provide an association with A, should I,
don't we have a mechanism for that for LLM function? What does
no, but LLM function is a single prompt. Yeah, so either you have everything or you don't. But here you have multiple nodes.
No, but
so
I thought it had a mechanism. If you don't have something, it just leaves it blank in an LLM function, right?
Oh no, I'm saying no. Sorry,
template apply. But in this case, sometimes we can go through part of the evaluation graph with part of the input and wait for more input in order to evaluate things for which dependency are unsatisfied.
The other input asynchronously, right? How would we get the input? I mean, you're specifying the input here by just.
So that would return a partially evaluated graph, and that's so it's yet another graph. Just like if we net initialize a net graph with only part of the weights,
Yeah.
And later on, we initialize more or things like that.
So is it the case that any LLM graph in any state of evaluation can be represented by an LLM graph?
This is what we do internally. Like we have this function that you use for evaluation, which is called LLMGraph submit, which is there simply to provide handlers, like handler functions, handler keys. And by the way, I would like to use like something like session submit for this. But it's very cumbersome to document specific handler functions and handler function keys in a generic submit function. Yeah, so like I don't love introducing new symbols for nothing, but the documentation is very cumbersome otherwise.
Well, that's a separate problem. I mean,
Yeah,
you mean to use session submit rather than to use LLM graph submit?
Exactly, but in that case, session submit would need to be extended. That when you submit an LLM graph, you have a different set of keys, which is a bit strange because it's a neutral function.
It's like what happens for the tasks, right? There are multiple kinds of tasks you can.
Yeah, but LLM graph, session submit and local submit, they don't look at the head of what they're submitting. I think.
Yeah.
The task contains all its options.
That's going to work. I think it's having a separate LLM graph submit. Well, I don't know, but okay. But so the main point you're making.
Okay, yeah. The point is like LLM graphs in the events. Like if you scroll down, we have an example of this in this notebook. Let's go down here, below the synchronous example. Okay, here you see like this thing here is doing the joke thing, and here we are showing you all the events that's generated. At every event, you can see the completion that was done, the current node that is doing something in that event, and then you have a copy of the original LLM graph. Of course, it's not mutable. Everything is immutable, but you have a new copy with all the resolutions that have happened up to that point. So it becomes basically richer and richer, and at the end, it contains all the resolved prompts.
I'm sorry, why isn't this an n-squared amount of memory?
No, why n-squared?
Because aren't you just accumulating everything and storing everything?
Only if you ask for it.
I see. Okay.
This is how the task framework works. I mean, I'm asking to produce all intermediate inputs, but otherwise it doesn't.
Fine. Okay. So let's see. I mean, so that's nice that the thing can represent all partial stages. So in other words, if there is a I'm sorry. What am I saying? If you're saying if this is incompletely filled, if I leave out N2 here, for example, what do I get back? Do I get back an LLM graph that is waiting for an N2 to be specified? Correct?
Exactly.
Yeah, that's nice if you can do that.
And one thing that is interesting here is like you could imagine that if you have an LLM making a plan, the plan could look like an LLM graph. And in that case, let's imagine that you have, I don't know, a failure at one point. You could fail and return the last LLM graph. Instead of like having to handle the failure inside, you could also exit the computation and return the LLM graph, and you will not waste time, because all the stuff that has happened before the failure is there.
Yeah, that's nice. Look, I mean, this thing has got to record the fact that it has. I mean, even in this case, the input. Well, here it doesn't have any input, I guess. But if N2 was missing, that would have an input saying N2, correct?
Well, instead of prompt one, write a template with some backtick and a slot, like input or like something argument.
Well, you said it's not going to run anyway.
Oh yeah, sorry. Yeah,
no, but yeah. But is it the case that if I delete the N2 thing here, that
yes, it is.
that will come back as N2.
Yes.
Exactly. The input will be N2. Exactly.
Okay. Well, I think this is quite nice. What is this?
So the idea is,
that's not needed.
Yeah, sorry, go, Timothy.
So the idea is that sometimes, just like you want to initialize some weights in that graph, you might want also to do some human in the loop or to bypass an LLM call and force the output of the node. So with this, you're like faking the LLM call, but providing the result yourself. And you're saying, I want node 1 in this graph to be set to this value as output. And then you would get another net graph where
the reason you're doing that is because the syntax here doesn't allow you to distinguish between a prompt and a literal. Is that right? Because this is just feeding a literal in for N1, correct?
Yeah, but in LLMGraph initialize, this is not setting the prompt, this is setting the results, the output.
I know.
Yeah, no, but I understand what you say, Stephen. Yes, you could replace N1 with the literal, and right. That
so
would be
words,
also N1 its own result.
Was verbatim or something, whatever it is, as opposed to the prompt. Right? Normally, you're saying N1 is a prompt.
Yes.
Yeah.
Yes. Yeah. Definitely.
Yeah, that's a nice idea. But then we need if you want to dynamically change it, we need either some form of mutation or like a replace part or something like that.
What do you dynamically change it?
I mean, one nice thing we have is like surgery. If you have already a form LLM graph, how do you impose it if you want to do it at a later date?
I don't understand.
So,
like, I was imagining that you might want to, for example, there's like some failure result in a LLM graph, and you say, okay, if this is a failure, the normal code which is managing everything, it has like a default of like, sorry, our knowledge base didn't have this result. Yeah, like you want a pre-formatted output in case of a failure, and you might want to inject that in the computation.
How would I do that? How would I know that it was a failure?
Oh yeah, because it might return a failure object. So this is what I was discussing before. Yeah, the LM graph, if it fails, we have this. We are suggesting to use a failure action option, which we found, and I don't think it's much used, because it fits very nicely with this function. And you could say that if there's no, like, if there's an LM error or a timeout or whatever, you can define like a failure behavior, and that could be a failure object. And the global LM graph could just return, the partially evaluated graph with the failure at the result of a node. And then it's up to you to decide what you want to do. I mean, maybe you want to rerun it, or maybe you want to supply a value in place of a failure.
I don't understand how it ever sees the failure object. Where is it seeing the failure object to trigger the failure action?
I mean, the failure, okay, can you open the page for failure action? This is a quite flexible framework. This is only used by queries so far, but if you open details, it has a bunch of interesting things that you can do here.
Oh, yeah. This was done before the confirm enclosed framework and so on.
I think so.
No, I know it was. It's not obvious to me that this is right. Okay, let's go through this again. Okay. The main point here is we're defining kind of a cascade of LLM functions where at some, okay, we're so if, and there are also those LLM functions can have tool calls. I'm still a bit confused by the fact that, that prompt, the full form of that is LLM function of the prompt. Is that not correct?
Yeah. Potentially with a dedicated LLM evaluator.
Yes. Okay, so the N1 could equally well just be a function f, right?
Right.
That takes an association of some kind. So this thing here is equivalent to ampersand, right? It's just a function that returns that verbatim string.
I see what you mean. Yeah.
Yeah, we could have that.
I mean, it might be nice to have some verbatim wrapper as well. I'm a little bit concerned about using verbatim itself because
it comes from the pattern word. Yeah.
Is it oh, does not maintain an unevaluated form. It'll be fine. It will be fine. I think. I think either of those forms could work. But this is the general case of where you could say, so I mean, if I wanted to, I mean, I could imagine a general function that has nothing to do with LLMs. Except I wouldn't know. I see. I wouldn't be able to do the dependency mapping if I didn't have it as a string template prompt. See what I'm saying? So
and
in other words,
on top of that, we would basically also we expect a format for the output, so we would need to enforce that.
No, but the main point is that in this form here, you can't really do dependency tracking, knowing what things you expect, so to speak.
Well,
I still think that
we could have a weak lexical check in the function slot, but that would be the max, the total extent of what we can do.
Yeah, well, still, but I mean, this syntax is, the problem is that you need another way to specify the dependency tracking, because this isn't going to be enough. So I think what you need to be able to do is to have a right-hand side here that says something like function inputs, blah, blah, blah. So a fully qualified form of this. You see what I'm saying?
Yeah, even cleaner.
Yeah.
So, I mean, okay, so if you can get that fully qualified form, then these become elisions of that make a lot more sense to me. Okay. All right, what else to figure out here? I like your schedule. I mean, that's clearly nice. What else do you want to figure out?
I think is mostly there. I mean, the rest is, I mean, this is overall like once we nail the syntax, the functionality is quite clear.
Fair enough.
And the point is like, this is something I discussed with Charles when we were like designing the graph with ports. In the end, we expect graph with ports and some form of graph evaluation to be a generic thing that can do whatever. But in practical cases, you very often, like system modeler has its own like graph evaluator. This one has its own. Like the point is, like
I'm not
it's
too worried
very
about this
complex.
case. This case is going to have lots of specialization because of prompts and so on. I'm not too worried
Exactly,
about having
exactly.
this be separately named.
Okay.
All right. Anything else to figure out here?
No, I think we can meet again when we have a proposal for LLM agent.
Sounds good. Hopefully that will be very soon. And when we do that meeting, can we bring in some other people who are more
Yes,
directly, users of the agent and so on?
absolutely.
Sounds good. Okay. Thanks to folks on
Thank
the
you.
live stream.
Thank
Okay.
you.
See you. Okay.
Bye.